Welcome from my side. My name is Michael Hanisch. I'm a solutions architect with AWS. And today I'm going to talk about auto-scaling. This is like a level 200 session. So first a quick question, like who of you is using auto-scaling already? Quite a few, OK. All right. So the session is not titled all there is to know about auto-scaling, but everything you need to know. So I'll try to focus on that. But I think we can have a longer time for Q&A at the end. So we can probably discuss some of the more advanced topics as we go along. All right. So let's get started. What I'm going to do today is basically give a basic introduction to auto-scaling concepts, like all the bits and pieces that you need to get auto-scaling set up and running. I'll talk about scaling policies, different kinds of scaling policies, how and when to use, for example, how you can control the instance lifecycle. And yeah, the basic goal for today is to give a good overview and give you enough ideas of where you could look to optimize your usage of auto-scaling. OK, let's get the basics out of the way. So what does it do, right? I'm going to focus on a fairly simple example. So let's assume that I'm like a small business owner. I have like my own ice cream shop somewhere in Vegas. And I have a website, of course, where people can reserve a table, for example. And since I'm smart, I care about availability. So I use like multiple web servers across 2 AZs. I've got an elastic load balancer in front. All is fine and well, right, until reinvent descends into town. And suddenly, my servers are like quite overloaded. So I figure, OK, I'm going to launch 2 more, right, set everything up, register them with the ELB so that I can keep going and people can get to a table actually quickly. And yeah, that's fine, right? So I notice an increase in demand, I notice an increase in utilization, and I want to adapt to that. And that's exactly what auto-scaling provides. So instead of doing that manually, like scaling up from 2 to 4 servers, I can also just leave that to auto-scaling and place my servers into a so-called auto-scaling group. That's the main and central concept to auto-scaling. The group has like 3 different variables: a minimum capacity, so how many instances do you need to keep running at all, and a maximum capacity, which is typically controlled by your budget, right? And somewhere in between, there is the desired capacity, which is what you believe, or what auto-scaling believes you're going to need. So now, once you've defined a group, given that a name, and set those parameters, auto-scaling will do its best to make sure that you always have the minimum capacity, the minimum number of instances running at any time. So it will launch or terminate instances to adapt its current capacity to your desired one. And it will assure you that it won't ever start more than the maximum number of instances. And another nice thing is that it works across AZs, and it works across subnets if you're running in a VPC. And whenever you have multiple AZs, for example, auto-scaling will work to distribute the desired capacity, or the current capacity that it has, across the AZs as evenly as possible to make sure that you won't get hit, like if any problem occurs in one of those AZs. All right, so back to this example. Let's say there's not only reinvent, but probably another conference as well. And suddenly I figure I need more servers. So all I need to do is basically say, OK, desired capacity, desired number of servers is 6, not 4, right? So I just tell it auto-scaling. And what it's going to do is it's going to launch 2 new EC2 instances, make sure they're up and running, and register them with the load balancer that you've configured. Then it's also a good benefit of auto-scaling that is well integrated with the ELB. But next question, of course, is how does it know what kind of server to launch? And the answer is launch configurations. That's the second thing you need to configure when you launch an auto-scaling group. So because the launch configuration tells the auto-scaling service what exactly it needs to launch. And at the very least, it needs to know which kind of AMI should it run, so what kind of software, configuration, operating system is in there, which size of machine you want, which type of machine you want. And then, of course, all various security settings, security groups, be it an EC2 Classic or in VPC, the SSH keys, the IAM instance profile, and a couple of other things. Basically, everything you need to launch an EC2 instance needs to go into that launch configuration, except for the AZ or subnet, because that's something that the autoscaling group will decide for you, depending on where the capacity is needed most. When you launch an EC2 instance, a regular one, you can always pass in this user data attribute. I'm not sure how many people use that when you just launch like any old EC2 instance, but in the case of autoscaling, it's a very important piece of the puzzle, because you just tell autoscaling what it needs to do, but all the rest needs to be fully automated, and user data helps you to do it. So the user data field is basically a place where you can put in a couple of kilobytes of arbitrary data, which will be transferred to your EC2 instance as it launches up. And typically, if you use a Linux instance, for example, you'll have like a CFN init process that will actually take the contents of that user data field and evaluate that. There's a syntax that just installs packages, but if it just starts with like hash bang, it will basically execute the whole thing as a shell script. Right? And that allows you to just start with a basic AMI and automate everything that happens on top of that. Or if you use a Windows instance with autoscaling, you can just put in a PowerShell snippet, for example, that will be executed as the machine is booted up. And that's important because the whole bootstrapping process, as I said, needs to be fully automated, right? It doesn't make sense if you have automated scaling, but then you need to log in and do something manually, right? And there's no right or wrong way to do bootstrapping. I think it's like a whole spectrum of different approaches. One approach on one end of the spectrum is to use a golden image, right? You basically create one Amazon machine image, pick the right OS you want, install the web server you need, configure it, install your application, all the assets it will probably need, and so on, and then create a new AMI out of that. The benefit is you just need to give that AMI to your launch configuration, and autoscaling automatically knows what to do with it, right? It will just boot up the AMI, and everything will be fine. Now, that works pretty well. You can also automate this process fully. If you do a lot of changes, you'll end up with a lot of AMIs, which adds the challenge that you need to keep track of which one is current, which one has changed this, which one has changed that. On the flip side, it's easy to roll back, right? Just create a new one, or basically roll back to the previous AMI, and you're good to go. But one drawback to this golden image approach is that you're tying together changes that occur at different speeds. For example, you bring in operating system changes, changes to the web server, changes to the configuration, as well as changes to your application. And they probably occur at different speeds depending on how much time you invest into developing your website. So that might be a bit of a problem. So what most people do and what I typically recommend is to split this out a little bit and just start with a base AMI. Right? So the question is how much you put in there. It could be just a plain vanilla operating system, or it could be the base AMI together with the general web server that you use, some kind of monitoring agents and so on. Roll that into a custom AMI and make that your base AMI. And whenever autoscaling boots it up, use user data, for example, to inject the current version of the application you want to run, any configuration items that this application needs. And then you'll boot up the boot image, and user data will do the rest. And where exactly you draw the line between what goes into the image and what goes into the user data script, et cetera, that depends a lot on the culture that you have, that your development team do, the amount of changes or the frequency of changes that occur, like in your code versus on the software you use. It will also depend on what kind of extra tools you use. So I'll show you an example of how to use user data. Like I said, you can just pass in a shell script that will be executed. That's one way to do it. But many people are also heavily invested into configuration management solutions like Chefware, Puppet, or Ansible. And that's also a good way to get this going, to take care of the bootstrapping process, which basically means pick your base AMI, probably one that is including like the Puppet agent, whatever, and make sure that whenever this image is spun up, it can automatically contact the Puppet master, for example. And then in the user data script that you put in the launch configuration, you will just need to reference the kind of role or the kind of task that this machine needs to fulfill. And then you can let Chef or Puppet or Ansible do the rest. And of course, another solution is to use AWS Code Deploy, which does pretty much what it says, right? It just deploys code, which it takes from S3, for example, or from other locations, and rolls it out. And it can do that just as well together with autoscaling. That's one example for a user data script. As you can see, it's just an arbitrary shell script. It just does an update, installs Ruby CLI, and then it basically downloads and installs the AWS Code Deploy agent. Right? So you could basically do that with like many flavors of Linux. It will just do the right thing. And then the Code Deploy agent will run, and then you can configure the Code Deploy service to actually tell it that this autoscaling group, which has this configuration now, should be part of a certain deployment group for your application. All right, so I think we've talked a bit about how we can get the bootstrapping process going and how you can actually get your software configuration onto your machines. Now, our 2 additional instances have booted up. Now we have like 6 of them, right? I think we're happy. CPU utilization will go down. People no longer have to wait for their requests. But let's look at the opposite, right? We figure out, OK, traffic is going down. We want to save cost. So we want to reduce the desired capacity to 5. And in this case, autoscaling will pick an instance and terminate it. But before that happens, it will deregister it from the load balancer. If that has been configured, it will wait until the grace period passes so that any connections that still might have been open to that instance will be drained. And only then it will terminate the instance. And now we have our desired capacity of 5. Now the question, of course, is how does autoscaling choose which of those 6 instances it will terminate, right? And that's something you can actually configure using termination policies. First of all, the important thing to know is that autoscaling will always work and always ensure that your capacity is balanced across AZs. So in our example, it was perfectly balanced. We had 2 AZs with like 3 machines each. So that's fine. So it could take a machine from any of those 2 AZs, right? And then once it has figured out which AZ where it can reduce the capacity, or where it should reduce the capacity first, it will consult the termination policy that you've configured to decide which instance to pick. And there are 3 different options as of now. First of all, you can get rid of the longest running instance first. Very useful if you tend to have memory leaks and such, right? But maybe you just want to clean up the old stuff. You can also get rid of the instances with the oldest launch configuration first. And it's also interesting because one thing I haven't said about launch configuration is that you can keep changing them during the life of your autoscaling policy, right? You have to define one launch configuration so that autoscaling knows what to do. But if your AMI change, if you decide on a different instance type, for example, you can just replace that launch configuration with a new one. And that won't affect the currently running instances or the currently running autoscaling group, but the next time it needs to launch a new instance, or 2 or 10 or whatever, it will look at that new launch configuration and launch those kinds of servers. And that's one way to replace operating systems, server stacks, application stacks, and so on inside autoscaling group. Basically just configure a new launch configuration and make sure that you basically cycle all the instances. Terminate the instances one after the other, and it will bring up instances that are in accordance with the new launch configuration, with the new software stack, and so on right away. And if you want to make sure that that process is smooth, you can choose the oldest launch configuration policy. That will always get rid of the oldest instances first and replace it with a brand new one using the latest configuration. The third option is useful for cost control. It will just delete those machines or terminate those machines first that are closest to the full billing hour. So basically the machine you got the most money and the most value out of, and leave the others run, right? All right. The third piece of the puzzle, besides launch configuration and termination policies, are the scaling plans. they basically determine when autoscaling will launch or terminate instances. And basically, it all comes down to current capacity that autoscaling is observing and whatever you tell it about its desired capacity. If you tell it you need more, it will launch more. If you say I want less, it will automatically terminate those. There's a couple of different scaling plans. So if you don't configure anything else, the default scaling plan will be in effect. And that just means that autoscaling will just sit on whatever instances you've launched and make sure that they stay up and running. If one of them fails, for whatever reason, it will replace it. But other than that, it will always stick to the desired capacity. Then, of course, you have the option to do what I call manual scaling, which basically means you can set the desired capacity using the API, command line interface, or the console on your own to trigger a scaling event. Obviously, it's not that much fun if you do that manually, though it's helpful for testing. But it's also a good thing because you can connect that to other systems, right? If you already have like a monitoring system or some kind of configuration system that takes care of how many instances you need and how much capacity you have, then you can just connect it basically via a shell script using the CLI tools to just set the desired capacity depending on whichever state your configuration management tells you about. Autoscaling also supports scheduled scaling. So basically, you tell it every morning at 8 o'clock, scale up. Every evening at like 6 p.m., scale down. And of course, and that's the most important thing and probably the broadest appeal of the service, is that it can scale automatically based on CloudWatch metrics. OK, so these are the three things we've covered so far, the very basics. The autoscaling group basically controls a fleet of servers, make sure that it always has the right servers running and the right number of servers running and balanced across AZs so that you're covered against instance failures, AZ failures, and so on. The launch configuration, which tells it which servers to launch. And finally, the scaling plan that tells the autoscaling service like when to scale in or out your fleet. And as I've said before in this example, it's not the only example, but it's a very common one, is where you integrate autoscaling with the ELB load balancer. Because many people use autoscaling for web-based workloads. And of course, if you have multiple machines, you need some point that acts as an entry point and can distribute the incoming traffic. The nice thing about ELB and autoscaling is that they are well integrated. So for example, ELB supports connection draining, as I've said before. And it tells autoscaling, like once the drain period is over and it's safe to actually terminate an instance that's about to be terminated. It generates metrics, which you can use in autoscaling as well. It interacts pretty well, and I guess I'll show you a couple examples later on. The interesting thing is that you can configure the autoscaling group to work with one or multiple load balancers. Right? So depending on how you set up your system, you might have multiple load balancers connected to the same fleet of servers, probably accessing the same web servers in different ports or stuff like that. And once you have connected an autoscaling group and an ELB, the autoscaling group will tell the load balancer whenever a new instance has been launched. It will automatically add it to the load balancer pool. And also, when an instance is due for termination, it will inform that as well. OK, so I think that covers the most basic points. And I think one of the main features of autoscaling is that this is like one of the places where like the cloud's promise of elastic capacity comes to life, right? Because you can really automate an infrastructure that adapts to demand. But it's not the only benefit. The other benefit I see is increased availability and reliability of your system. Because autoscaling does health checks. It does those periodically. And it keeps track of which instances are healthy or unhealthy. And if an instance doesn't look as good anymore, it's going to terminate it and replace it with a new one. So that's also part of the default scaling plan. As soon as something seems to fail, it will be replaced. And there's a couple different options for health checks. So the default is to just use the EC2 health checks, which you can also see in the EC2 instances list or console. If one of the instances is not running, so for example, if you terminate it manually, or if the system health check or system status is impaired, autoscaling will automatically recognize that instance as bound to fail, and it will replace it right away. Now, if you have an ELB in front of your fleet of web servers, the ELB has its own health check, which is like on an application level. So it does an HTTP call, or a couple of them actually, and looks for a 200 response code. And if it does see that, then everything is fine. If it sees something else, like a 503, for example, it will mark the instance that actually returned that code as unhealthy. And if the ELB is connected to an autoscaling group, you can configure the autoscaling group to automatically use the ELB health check instead, or in addition to the EC2 instance health check. So whenever the ELB doesn't get the reply it wants to see, it can tell the autoscaling group to replace the instance right away. And of course, everything has an API, so you can mark individual instances as unhealthy, right? Using command line tools, using a connection to your own monitoring system. So you can define your own health checks and define your own rules for when an instance should be replaced. So you could tie that into various metrics. For example, if, I don't know, disk I/O seems to take too long, or disk is running full, or whatever, you could basically have that trigger an instance replacement. All right, so what does it look like? If we look at our example from before, we have our 6 web servers. If any of those instances fails a health check, whether that's an EC2 health check or the ELB health check, it gets replaced right away. Because if you look at this right now, we're below our desired capacity. So that's when the scaling plan kicks in. It just says, OK, I need another instance to satisfy demand. And the same is true as well if, for example, a whole AZ would fail, or the connectivity to a whole AZ fails, right? Autoscaling can balance across multiple AZs. And in this example, it will always try to balance across both of them. But if one of them is not reachable for whatever reason, there could be a network split or a power issue, it will make sure that the capacity that has fallen away here gets replaced in the other AZ. It will automatically tell the load balancer to take care of those new instances and add them to the pool as well. Now, this doesn't last forever. So as soon as the first AZ in this example comes back to life, it's available again. And autoscaling will keep trying to launch instances there for a number of times. And if the first instance launch succeeded, it knows that the AZ is alive and well again. And then it will start rebalancing. So it will then figure out, OK, I want 6 instances. I have 2 AZs, so I guess that means 3 in each. And it has 6 in one of them, so it's not really balanced. So it needs to move 3 instances from one AZ to the other. And that's pretty much the only case where you can go above the maximum capacity for a short amount of time, because autoscaling doesn't just shut down 3 of those instances right away, because that will bring down your capacity much too low, and you will see failures and whatnot. But instead, it will launch up to 10% of the capacity that you have in AZB in AZA. Wait until those are online, until they've been added to the web server, and only then it will terminate the now superfluous capacity in AZB, right? So worst case, if something extreme happens like that, so if we had like 10 instances in AZB, it would need to rebalance. So then it would launch one after one in the first AZ until it's rebalanced again. So for a short amount of time, you can go up to 11 instances, right? That's something you need to be aware of. But I think it does the right job because it always works hard to ensure capacity above everything else. And that's the second big benefit, I would say. It counteracts failures, whether that's instances failing, applications failing in case of an ELB health check, or whole AZs failing, unlikely as that is. And that's also one reason why people sometimes use autoscaling groups that have a min and maximum capacity of 1, right? You can just run an autoscaling group that always has like 1 instance in it, and it will do its job to just keep that instance alive. And if it fails, it will replace it with a new one. But you will always have like 1 machine up and running all the time. And it can also move from one AZ to the other if necessary, right? If you configure this autoscaling group in multiple AZs. That's also a neat trick. Now that EC2 supports instance recovery, that's less common, but it's still something that's very useful to know. because you can also relaunch one instance across multiple AZs. Okay, let's have a quick look at the various flavors of scaling policies which we have. So now a scaling policy basically tells autoscaling when to change capacity. Okay, there's 3 different ways to do it. So first of all, you can tell it how many instances you want, right? I mean, that's fairly static. It's also useful, especially if you have like scheduled scaling, right? So if I want to have like an intranet application for my ice cream shop, I can probably shut it down at night. And as soon as I open up again, I can have a scheduled scaling, a scheduled scale out that actually increases the size of my autoscaling group and then sets desired capacity to 1 or 2 so that I'm good to go for the day. And then as the business winds down, it can shut everything down and go back to 0 just to save cost. Outside of scheduled scaling, this is probably something we don't see as frequently unless you're integrating with another kind of management layer that already knows exactly how much capacity things should be there. Then it's also one thing to just basically tell the autoscaling API how many exactly you need, and we'll take care of that. What we see more often is that people ask for a fixed number of instances to be added, but you can also add or remove a certain percentage of the available instances that you have right now. So depending on how fast you scale, how fast you anticipate you need to scale, you can choose one or the other. Scaling on a schedule is very useful. It's useful for things like batch processing, probably not as useful for web loads, unless you have something that is very predictable. So for example, people probably go and get ice cream around noon, or maybe after work, or probably like all around the day on a weekend, right? But probably not for breakfast. So you can automatically anticipate that demand and have like a schedule that says every weekday at, I don't know, 11 a.m., just scale up a little bit so that I'm prepared. There's 2 different ways to do it. There's a cron-like syntax, which you can use. And that basically does what it's supposed to do. It's useful for recurring scaling events. You can use a cron-like syntax and do a scale-up event like every second Monday, for example, or like every day at 12:15, I don't know. But you can also schedule individual events up to 35 days in advance. If you're planning like big launches or campaigns or whatever, you can anticipate that and schedule in advance. That's not available in the management console in case you're looking for it, but it's available in the CLI and in the SDK. Now, most people probably use autoscaling because of dynamic scaling policies. And they just trigger scale-ins or scale-outs based on demand. And the demand is based just on metrics. And what it does, it allows you to define a number of different scaling policies. So scale up a little bit, scale up hard, scale in very quickly, for example, and tie those map those to changes in the metrics and certain levels of change in the metrics. Those metrics come from Amazon CloudWatch. So if you have EC2 instances, you get those metrics for free anyway. They're collected on a regular basis. You collect metrics on CPU usage. That's probably the most common one that's used with autoscaling. But you can also monitor network traffic and so on. And once you have a metric, it could be a custom metric as well. So you can put in an application level metric into CloudWatch and then use that for autoscaling as well. As soon as you have identified the metric, you can define an alarm, which basically means you set a certain threshold at which a scaling policy should apply. And as soon as the alarm changes its state, it will trigger the alarm, or you can define that the alarm threshold needs to be breached for a certain number of periods. For example, for 5 minutes in a row, and only then start scaling, because you probably don't want to scale like on every spike in CPU utilization. How do these alarms work? All of the instances in the autoscaling group emit metrics right away. which allows you, for example, to get the average CPU utilization for the whole autoscaling group. You don't need to know which instances are in there. You just need to know the name of the group. You can ask CloudWatch. It will tell you what the current average, maximum, and so on is. And then, as those metrics are collected in CloudWatch, you can define an alarm that fires whenever the CPU utilization goes up too high. This alarm you can then connect to an autoscaling policy as well as to SNS notifications and so on. And when the scaling policy fires, it triggers a so-called scaling event, and that's when you tell the autoscaling group, I want to have 10% more instances, or I want to have 2 instances less than I currently have. And when that happens, the new instances are brought online. They're added to the group. So CloudWatch starts collecting metrics for those instances as well. So at this point, you should see a drop in the CPU utilization. And the instance is registered with the load balancer. Now let's look at a quick example to see how that behaves over time. I'm just covering CPU utilization. And I want to scale up whenever I'm at 62% or something like that. So CloudWatch will keep monitoring CPU utilization across my whole fleet. And at this point, it will notice, yeah, OK, it doesn't fit. So it will actually trigger the alarm state. But I've set my alarm to not fire right away, but I've defined it to fire 2 minutes later. Because I want to make sure that I don't see just a little bit of spike for just 5 seconds and launch a new instance, right? Because by the time the instance is launched, everything might be over again. And this time is the evaluation period. That's something you define when you define the alarm. And now once that is done, you'll raise a scaling event. So autoscaling group will add a certain number of instances. And it will then wait a certain amount of time to give the instances actually a chance to get spun up, to get the web servers up and running, before you will actually start to see a decrease in the CPU utilization. Because it will take a bit of time to get the instances up and running. It can take 1 minute, can take 5, depending on how much you load, how big your AMI is, right? And you can specify the cooldown as a default for the group, or you can also specify a cooldown just for a particular scaling action. And one challenge here is that during this whole period, during the point that the alarm triggered and we started evaluating, and the time the cooldown period is over, there aren't any more additional alarms or additional scaling actions possible. This makes it challenging sometimes to use, let's say, scaling based on different metrics, right? Because while CPU utilization might be fine, some other metric that you might want to monitor might be in breach, for example, but nothing will happen during this amount of time. And it could be worse, because there are cases where maybe it doesn't work out as nicely, right? And you just bring the capacity online in time, but where utilization goes through the roof, right? And if we actually looked at when this alarm would have fired, 2 minutes later, because we evaluate everything for 2 minutes, it might have been way too late. We were almost 90%, something like that, which might be too close to actually launch a different capacity and bring that online before you run out of capacity and before customers start seeing errors. And that's the main reason why the autoscaling team launched step scaling policies in the last year, because they address this particular challenge, and they give you a bit more flexibility on how aggressive you want to react to breaches in your metrics. Now, in the step scaling policies, you can't define just one step. You can say, OK, I'm in breach of this CPU monitoring metric, so I want to add 10%. But you can actually define multiple steps depending on how much you're over your target. So if I said 60-something%, right, and it monitors 80%, then probably the reaction will be different than when it monitored 65%, right? Then I don't have to react as aggressively and as quickly. And the other thing is that the scaling policies are evaluated continuously. So there is no cooldown period that blocks the whole thing. So if, for example, I breach the threshold, I'm at 65% utilization, it will start scaling out somewhat gently, right? But maybe then it goes through the roof. It is like 80, 85%. Maybe then another rule would kick in and start adding much more capacity so that I can anticipate that growth and I don't run the risk that my capacity comes online too late. And since it doesn't lock, additional alarms can fire at the same time, which means that now you also have the opportunity to use additional metrics for your scaling policies as well, because they no longer will block each other out. You can define them using the CLI API, also in the console. Right now, that's actually the default experience in the console, because you can now define multiple steps, multiple actions that you can take. And as you see here, for example, with CPU utilization between 30 and 50, let's say, I'm just going to add like single instance. If it's like between 50 and 70, I'm going to probably add two more, right? But when it's above 70, I'm just going to add 4 because it seems to be growing. And the actual values don't matter, but what matters is that now you can actually figure out like where to place the thresholds. You can have not only one, but multiple thresholds, and make sure that you pick the right strategy to actually address the metrics that you see over here. The simple scaling policies used to be the only option until a couple of months ago. They always have the same reaction, so you can't adjust to like how bad it is, how bad your CPU utilization looks right now, and it locks everything up. They're easy to understand, but typically step scaling policies are the better choice because they continuously react, which allows them to react much, much faster. And they give you more options because now you can actually have multiple metrics and so on. They don't support the cooldown configuration, so even if you provide one, it's not taken into account. But they have a warm-up period instead. It sounds pretty similar, but the implementation is a bit different. So while the cooldown basically meant that no scaling action took place and the whole group was basically locked for scaling until the cooldown period was over, the warm-up doesn't lock anything. It just means that the new instance is brought up, and then you can specify a number of seconds it takes to get this instance into service. And during this time, CloudWatch won't collect any metrics for this particular instance. Right? And the idea behind that is the instance might take a while to warm up until the caches are filled, until the servers are all running, the daemons are all running, before you will actually see an effect on your CloudWatch metric. Right? And you don't want to risk like triggering another scaling step just because you're like a second away from actually getting the new web server online. So if in doubt, use step scaling policies. I guess that's the key message here. I think that's something that many people aren't aware of, especially if they've been using auto-scaling for a while because they're fairly new. But they're usually the better choice. All right, we've talked about how to scale in, how to scale out, when to trigger that, how to trigger that. We talk a bit about launch configurations, how you can pick the right instance, how auto-scaling decides which kind of instance to launch. Now let's talk a bit about what the instance lifecycle looks like. So basically you have a group that's humming along. You have instances that are inside that group that are running. Then some kind of scale out event occurs, even whether that's like triggered by CloudWatch or triggered out of schedule. It means that the auto-scaling group will be told, okay, you need to launch additional capacity. When that happens, it creates a new instance that's in pending state, right? So it doesn't collect metrics, it doesn't register it to the ELB until that instance is actually up and running, until it's in service. And if then the health check works, it stays in service, it's registered with the ELB, for example, until it fails a health check or until a scale-in event occurs, and then the instance moves into the terminating state and the terminated state. Okay, fairly straightforward state machine. Now, if you want to take more control, you can actually hook into those lifecycle transitions. That gives you quite a bit of control over how exactly instances are launched and terminated. Why would you want to do this? There's a couple of common things that people always do or ask how to do it. For example, I have like a pool of elastic IP addresses. Whenever I launch a new machine, I want to assign one, right? That's something that you could do on startup. Or you want to register your new instances with, like, I don't know, your own DNS, subscribe them as workers to a queue, for example. Or probably the most common case and most common requirement I've heard is that, oh, we have log files on the instance storage. We want to save them to S3 before the instance is terminated. Very common thing. That's something you can finish or you can achieve using these lifecycle hooks. How does it work? Well, that's what we've just seen. It basically, as soon as you configure lifecycle hooks, either for termination or for launches, it will add a couple of different states. So for example, if you want to have a lifecycle hook on instance launches, the instances aren't launched right away, but they're put into a pending wait state. And you can keep them there basically as long as you like. By default, if you don't reply back to autoscaling after like 60 minutes, it will terminate it because it thinks that something went wrong. But basically, you have a lot of time to actually do something to the instance, like install software, assign EIPs, attach EBS volumes from a snapshot, for example, if you like, if you want to distribute files that way. And then once you feel that you're done, you tell autoscaling either to continue, then the instance will go in service, will register with the ELB and so on, or you can tell it to abandon the lifecycle hook, and then it will go into terminating right away, right, if anything goes wrong. And the same is possible if you take care of terminations. The instance will enter a terminating wait state. That basically gives you time to take care of your log files, move them into a persistent storage, for example. And when you're done, you just tell it, and it will terminate the instance. The only thing to watch out for, once it is in terminating wait, the only next state is terminating. It's terminated, right? So you can't go back into in-service. So no matter what you do, it will always terminate later on. How do you do it? Basically, first you need to create a target for the notification. And as soon, for example, as a new instance launches, as a new instance would launch, for example, the pending wait state, autoscaling will send a notification to the configured target. And that can be an SNS topic or SQS queue. Obviously, for autoscaling, the autoscaling service to do that, it needs to have permissions to access this particular queue or topic into your account. So you need to define an IAM role that the autoscaling service can assume, which gives it the permission to write into this particular topic. And then you associate the lifecycle hook, basically the name, with your autoscaling group, tell it when it should fire, so either on launch or in termination, or actually both. And then you need to write the code. So that's easy said, but also easy done. This is what the notifications look like that you get. And those should give you some ideas of what you can do in your lifecycle hook. First of all, it tells you which autoscaling group this is about. So it gives you an opportunity to hook the same system into multiple autoscaling groups, which is useful. It tells you the name of the hook, so you can choose the behavior based on that. It will tell you the instance ID, so you can immediately act on that and, for example, assign an EIP or attach the EBS volume. And it tells you which lifecycle transition you're in right now. In this case, it's just launching an instance versus terminating. So you can use the same hook for both if you like. And an important thing here is the lifecycle action token. This is basically a unique ID, which you need to pass back to the autoscaling group whenever you want to continue or abandon the process. Or other option, if you say 60 minutes is not enough, I need more time to keep autoscaling from terminating that pending instance, you can just tell it, okay, I've made progress, but I still need some more time. Here's the token. And it will give you some more time in addition to finish whatever work you've been doing. Okay, and how does writing a lifecycle hook look like? You can pick any programming language you like, doesn't matter. You just need to extract the information you need. You need at least the token, so you can talk back to autoscaling. You probably need the instance ID so that you know which instance you're working with, and some other parameters. Remember the token, yes, it's useful. Then do whatever you need to do, like move away log files. And then once you're done, call complete lifecycle action, passing in the token to tell autoscaling when you're done. And then it will move the instance into in-service state. At this point, if you call complete lifecycle action, you need to tell it whether to continue or abandon. And depending on what you pass in there, it will execute additional lifecycle hooks or not, because you can have multiple hooks on the same autoscaling group. So for example, if you have one hook that takes care of EIPs, one of what takes care of EBS volumes, you can connect them to the same group, and they will run one after the other, basically. But of course, if one of them abandons, then the other one will be abandoned as well, and the instance will terminate. Okay. Now, the lifecycle hooks use SNS notifications, or they use messages in an SQS queue. But if you've been working with autoscaling for a while, you're probably aware that autoscaling has been supporting SNS notifications for, I think, years. So the question is, how are those different? And the main difference is that the regular notifications that autoscaling sends to SNS, they only get sent after something happened. They get sent after an instance has entered the in-service state and is ready for use, or after an instance has been terminated. So obviously, if you care about your log files, this will be too late. So that's exactly when lifecycle hooks come in, because they allow you to actually influence the state transition, enter a wait state, and they will tell you before something happens. So you can actually anticipate what's going to come and react to that before it happens. Versus the other notifications are mostly useful for auditing and keeping tabs on what's been going on with your group. All right, coming back to the overall life cycle. One thing that's worth calling out is that, as I've said before, if you have an instance that is in the terminating wait state, the only next possible state is terminating, right? Terminated. So the instance will be gone, basically. So everything you need to do, you can do a lot on that instance. You can try to keep it running by extending the timeout that autoscaling gives you and whatnot, but you can't bring it back to life. At some point, the instance will be terminated. But there are cases when this is not desired. So for example, if you notice that something weird has been going on your instance, you want to do a bit of forensics, or you just want to have a look at the current state and so on, you probably don't want to have it in service, right? But you don't want it to be terminated because, yeah, you might be able to use it. And that's where another state comes in, and that's the standby state. And that pretty much does what it says, with the benefit that you can go back into the in-service state. So that's very useful if you just want to have a quick look at an instance. You can basically tell it to enter standby. That's an API command or a CLI command. Then you can log into that instance, for example, have a look at what's going on in the log files, is the disk filling up, whatever's happening there. You can even make changes. Then once you're done, you can just exit the standby state again. And then once it goes back into in-service state, autoscaling will react, re-register this instance with the ELB, et cetera, et cetera. So that's another benefit of autoscaling, that it allows you to customize something that's usually very automated. You can override launch configurations, you can override the lifecycle hooks. It gives you a lot of opportunities to actually influence the behavior of that group. Now, before we start with Q&A, I just wanted to do a brief outlook because we have a couple people that have been using autoscaling. But for those of you that haven't been using autoscaling that much, there are like two things I'd like to call out. So first of all, autoscaling works very well with spot instances. I haven't covered that right now, but it's very straightforward and easy to use, right? So all you need to do is basically create an autoscaling group, associate that with a bid price, and once you get the spot instances, they will be launched. They will be part of the autoscaling group, which means if they fail for some other reason than the spot price changing, they will be replaced and so on. And it just allows you to save cost. Because what's interesting here as well is that you can combine multiple autoscaling groups. You can have one that runs on on-demand instances and scales fairly conservatively, for example. And you can have another one that scales more aggressively based on spot instances, right? And tie them to the same load balancer. So if the load increases, autoscaling will try to add more spot instances first, for example, because they're cheaper and you've configured it that way. But for example, when it can't get any more spot instances because the price has risen, or I don't know, when that happens, then you can automatically, or you will automatically launch additional on-demand instances to fulfill that demand for capacity. That's one option to do, one thing to do. And the other useful thing is that, and I've alluded to that earlier, is that you can handle things like rolling deployments using autoscaling groups, right? One straightforward example is to just update the launch configuration, replace that with a new one, and then just terminating the instances one by one. Everyone that's terminated will be replaced with the new one, with the new AMI. Then you're good to go. But also, for example, if you use code deploy, if you set that up as I've shown earlier, if you connect the autoscaling group to code deploy directly, then you can also configure a rolling update across your autoscaling fleet without having to rely on autoscaling to recycle instances. All right, that's the end of the presentation. So thank you very much for listening, getting up early.